dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Okay, welcome back from Forest. My students, so we came across what we call Introduction to Organic Chemistry, the definition of organic chemistry, again the importance of carbon. We came across, we arranged organic chemistry into families in order to make a sense. So we shall go through our new lesson. So we have to start our new lesson, what we call hydrocarbons. So hydrocarbons is divided as compounds containing only carbon and hydrogen. I want to say it again. We came across organic chemistry is instead of carbon substance, or just say carbon. Then some of the compounds contain only carbon and hydrogen. Others, they contain carbohydrogen and with other substances. Those are not called hydrocarbons. So what are hydrocarbons? Hydrocarbons are compounds containing only carbon and hydrogen. So carbon is very important. It is the bone. It is the skeleton of the organic chemistry, and hydrogen is always attached to the carbon atoms. But some of the times we can replace hydrogen with another atom. For example, oxygen, sulfur, nitrogen. Again, I can say halogens. So compounds containing only carbon and hydrogen are called hydrocarbons. So hydrocarbons are classified into what? Saturated and unsaturated. Here you see hydrocarbons are compounds containing only carbon and hydrogen. So only carbon and hydrogen. So compounds containing, here you see compounds containing here you see compounds containing only carbon and hydrogen. Only carbon and hydrogen are called hydrocarbons. For example, what about this one? It contains carbon and hydrogen. We don't care the number of atoms. It contains 1 carbon and 4 hydrogen atoms. So we don't care the number of atoms. How many hydrogens are attached, how many carbons it contains, we don't get that one. But it contains only 2 types of atoms, carbon and hydrogen. Those are called hydrocarbons. What about if it contains more than 2 elements, like this one? You see, you are familiar this compound. Most of the students are familiar this one. Say 6. Here we have 12. Say 6. This is called glucose. It contains carbon, hydrogen, and oxygen. So at this time I can't say this is hydrocarbon because it contains extra atoms. It contains oxygen. It contains another atom. Well, so at this time I can't say hydrocarbon. So what are the hydrocarbons? Hydrocarbons are compounds containing only carbon and hydrogen. These are called what? Hydrocarbons. So hydrocarbons are classified into what we call saturated hydrocarbons and what we call unsaturated hydrocarbons. So this is very important. So students should differentiate these two. So hydrocarbons are classified into what? Saturated and unsaturated. So what are the saturated hydrocarbons? Saturated hydrocarbons contain single carbon-carbon bonds. So they contain single bond between all atoms, single bonds. For example, consider this one. This carbon, it contains a single bond. Again, it contains a single bond. Again, it contains a single bond. And here it contains a single bond. So all bonds are single bonds between atoms or in between atoms. For example, carbon single bond carbon, carbon single bond carbon. These are called what? Saturated hydrocarbons. We can put it another way. You see carbon, this carbon, we already mentioned it. It has what we call, it has 4 electrons in this outer shell. 4 electrons in this outer shell. So it requires another 4. It requires another 4 electrons to form bonds. To form what we call bonds. So it can react to hydrogen, here is hydrogen. So every 2 electrons may form a single bond, here is a single bond, here is a single bond, here is a single bond. So at this time, carbon can form 4 single covalent bonds. When it contains 4 single covalent bonds, 4 single separate covalent bonds, is supposed to be saturated. We can put it another way. Every possible location is attached by hydrogen. At that time, it is called what? Saturated hydrocarbon. What about if it is contains, if the hydrocarbon, you see this is hydrocarbon, and this is hydrocarbon. Same principle with the previous one. These are hydrocarbons. They contain single bonds between all atoms. But this group, or these groups, they contain triple bond and double bond. So if they contain what we call a double bond or triple bond, these are called multiple bonds. If the hydrocarbon contains double bond or triple bond, it's supposed to say what we call unsaturated. Unsaturated, which means you can add any other atoms to this unsaturated molecule. But if it is a hydrocarbon which is saturated, you can't add another atoms. So these are the differences between saturated and unsaturated hydrocarbons. So you can easily say what? Simply say, you can say contain single bond between all atoms. They contain multiple bonds. Say double bond or triple bond. Double bond or triple bond. Double bond or triple bond. Okay, here. Okay, consider this one. These are the different types of formula. You see, organic compounds contain different types of formula. When I say formula, it is a plural. It's a plural. So different types, different kinds of formula, organic formula. You see, we came across this one. For most of the students, you came across this one, what we call molecular formula. So molecular formula so it always express it is an expression showing you what it shows you the exact numbers of atoms in each element in a molecule. For example, here we have C4H10, so this is called butane. So this is a very concise. It contains 4 carboatoms and 10 hydrogens. What about, can I rewrite the empirical formula of this one? Empirical formula is the simplest whole number ratio that atoms can combine. So again, consider this one. It was C4H10. It was C4H10. So shall we write the empirical formula of this one? So empirical formula we can describe as the simplest whole number ratio, not what we call a fraction or decimals. So it's supposed to, it shows you simplest whole number ratio that atoms can combine, can react. So the empirical formula of butane is C2H5. C2H5. So the simplest ratio, this one it was C4H10. Actually, it was what? C4H10. So can I deduce the empirical formula from this one? Yes. Without writing decimals or fractions, yes. So the simplest way is C2H5. What about, can I reach up to 1? If I divide again into 2, this 5 should be what? 2.5, and atoms can't be what? Decimals. Which means if I write, for example, I can put here, for example, if I do it again like saying 2.5, which means 1 carbon will react with 2.5 hydrogen, and it doesn't exist, 2.5 hydrogen. It is like human. So there is no what we call 2 persons and 2 boys and half. It doesn't exist. It doesn't exist. So atoms are always we can write in a whole number. So we don't want to write in a decimals. So the simplest ratio of this one is C2H5. 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 What about general formula? So this general formula, sometimes it is called family formula. Family formula. So family formula and general formula is the same. So each family should have what we call this formula. This is called a general formula, family formula. For example, each family like alkane, alkene, alcohol, carboxylic acid, ester, ether, aldehyde, amide, whatever, they have a formula. So this is for what we call alkenes. What about alkenes, for example? Alkenes, they fit another formula. What about alcohols? They do another formula. What about carboxylic acid? They have another formula. So this is a general formula. It's an example. So this is called a family formula. Family formula. What about the structural formula? You see structural formula. Structure formula I choose structure formula. So there are two different structure formula. One is called condensed. This one is called condensed structure formula. The other one is called expanded formula. So we shall see that one. So this is condensed structure formula. This kind. So this kind is called the structural formula. This kind is called the structural formula. For example, we want to write the structural formula of butane. It was C4H10, and this is C4H10. If you count the number of atoms, how many carbon atoms we have here? We have 4 carbon atoms and 3, and say 10 hydrogen atoms. So this is condensed structural formula. So in the exam, we can ask you write the structural formula of butane. Again, bentane. So you have to write it. So if you were asking the structural formula of butane and you read the molecular formula, that's very wrong. That's wrong. Okay, what is the other structural formula? The other structural formula is called a display. This shows you all bonds. It shows you what we call all bonds. All bonds and atoms. For example, displayed formula of butane. Displayed formula of what we call butane. Consider this one. It is displayed formula. If you count the number of atoms, it is 4 carbon atoms and 10 hydrogen. Same principle with the previous one, but this indicates you all atoms, again all bonds. All bonds. So this is called a displayed formula. The other one, the previous one, is called what we call condensed structure formula. So displayed formula, sometimes you can say expanded formula. Expanded formula. A skeletal formula, it shows you carbon skeleton. For example, carbon skeleton. So it contains 4 carbon atoms. It contains 4 carbon atoms. 4 carbon atoms. So I want to write 5 carbon atoms. So here we have. So go back. So I want to write here. So for example, I want to write 5 carbon atoms. This is 1, 2, say 3, 4, 5. What about if I want to write 7? I can say 1, 2, 3, 4, 5, 6, 7. So here is 1, 2, 3, 4, 5, 6, 7, which means you are showing only the carbon atoms. So we don't get the number of hydrogens. What about what we call the other formula? The other formula are called ball and stick model. These are models, space filling model. So these are not very important in our specification. So here you have 6. Here you have what? 6 different formula. So these are the organic formula. So I want to summarize my lesson here. Thank you, my students.